Hello, this is a brief recap of week 3 of our electrical engineering workshop. Let's first talk about Boolean values. Booleans tell us if something is true or false, like answering a yes or no question. In an electrical circuit, imagine a single button controlling the flow of voltage. If the button is pressed, voltage flows through the circuit. This corresponds to true. If the button is not pressed, there is no voltage, or false. It's like answering questions. Is the button pressed? Yes or true means voltage flows, and no or false means no voltage flows. Booleans help us understand and control whether the voltage is on or off based on the button being pressed. Now that we understand what Booleans are, we can define a few operations that use them. The AND operation takes in two Boolean values and tells us if they are both true. Here, 1 and true are basically the same, and 0 and false are also the same. So, if we take a look at the first row of this table, we are saying that when both inputs are true, we get true. The second and third rows show that if either input is false, then we get false. And the last row shows that if both are false, we still get false. Let's say I told you that I have two Boolean values, and one of them was false. Take a second and try and figure out the output of the AND operation on these two Boolean values. If you look at the last three rows closely, you can see that at least one of the inputs had to be false in order for the output to be false. So we only need one input value to be false to determine that the output of the AND operation will also be false. The OR operation also takes in two Boolean values, but this time it tells us if at least one of the inputs is true. Only when both inputs are false does the OR operation on those inputs end up being false. The XOR operation is very similar to the OR operation. Can you spot the difference? If you look at the first row, you can see that if both inputs are true, the output is now false. XOR tells us if one and only one of the inputs is true. Another way of thinking about the XOR operation is that it outputs true when the inputs are different and false when they're the same. Unlike the previous operators, NOT only takes in one input value. NOT simply outputs the opposite of the input. True becomes false and false becomes true. Now we can combine these operators. One example of a combination of other operators is NAND. Can you guess which two operators make up NAND? We can think of the NAND operator as applying the NOT operator to the output of and two inputs. Tying this back to electrical circuits, 1 or true corresponds to voltage, while 0 or false corresponds to no voltage. We will now explain how we can perform Boolean operations in our circuits. We use logic gates to perform operations like AND and XOR. In this diagram, we can see that there are 4 operators. In order to use these operators, we must connect the voltage pin in the top right to the positive end of the battery and the ground pin on the bottom left to the negative end of the battery. If we pretend like this logic gate is an AND logic gate, and we connected positive voltage to both input 1A and input 1B, we would get a positive voltage out of the output 1. Now we want to use XOR, which checks whether one and only one of the inputs are true, to power an LED when one and only one button is pressed. We start by placing our buttons and logic gate on our breadboard. Because the pins on our logic gate are not symmetric, we need to pay attention to the orientation of our logic gate. To use our logic gate, we must connect the top right pin to the positive column and the ground to the negative column. Now we want to connect the buttons to our logic gate. We're going to use the buttons to determine whether there will be voltage or no voltage on the input pins of the logic gate. If we simply connected the positive end of the battery to our button and then connected the other end of the button to our input, our circuit will not work as intended because it is not a complete circuit when the button is not pressed. We need to find some way to make sure that the circuit is closed when the button is not pressed. To do this, we connect the input to the negative end of the battery. When we make this connection, we must use a resistor to prevent a short circuit in the case where the button is pressed. This is what connecting the buttons should look like on a breadboard. The first input pin is connected to the plus column when the button is pressed, and it is connected to the minus column when it is not pressed. Now we can connect the other button to the other input of the same operator on the logic gate, and that operator is highlighted in blue. And finally, we can connect the LED using the output pin, and I will now demonstrate this. Here we have our XOR gate. We will first start by powering our XOR gate. Next, we will connect our two buttons. Remember to ground your inputs. Now that our buttons are connected, we want to connect our LED circuit. To do that, we will want to take the output of our XOR operation and use that to supply voltage to the LED. Lastly, we need to connect our plus columns and our minus columns and then test our circuit. To test our circuit, we can use either a battery or a voltage source. Make sure you're using no more than 5 volts. Now, pressing either button should illuminate the LED. Pressing them both, however, should keep the LED off. And there you have it. Now let's see if we can make a NOT operation using the XOR logic gate. Remember how XOR tells us whether two Boolean values are different or the same? If we XOR any input with true, or positive voltage, we get the opposite of that input, thereby creating a NOT operation. I'll now demonstrate this. Now we're going to try and take our same circuit and build a NOT gate. To do this, we will remove one of our buttons. Now that we've removed the second button, what we want to do is we want to take our input from this button and XOR that with voltage from the positive column. This is like XORing with 1. Now we can test our circuit. As you can see, when the button isn't pressed, our light is on. When it is pressed, the LED turns off. Thank you for watching.